Good day wherever you are viewing us from, and you are welcome to MLT channels. Today's subject matter is further math, and the topic of discussion is logarithms. By the end of class, learners should be able to derive the product rule of logarithms, as well as applying this rule to solve simple, moderate, and difficult questions involving product rule of logarithm. Now, without wasting much time, let's dive straight into the topic. So, what is the product rule of logarithm? The product rule of logarithm goes thus: if we have log p assume we have log p base a multiplied by log q base a, then this is equals to log p plus q base a. This is the product rule of logarithm, and this is what we want to prove or derive in this class. So let's start. To start, let's first make p equal to a raised to power x, and we call this equation 1. And we also make q equal to a raised to power y. We call this equation 2. Then the next thing is we take log on both sides on the equation. Take log on equation 1 and equation 2. Then we take log on equation 1 and 2. That implies that we have log p now. We have log p equals to log a raised to power x, and let's call this equation 3. Then we also have log q equal to log a raised to power y, and let's call this equation 4. So we've taken log on both sides like that. The next thing now is to apply exponential of logarithm on equation 3 and 4. Apply exponential law. And what's exponential law? We'll look at exponential law in the next slide. Exponential law of logarithm states that exponential law of logarithm says that if we have log x raised to power n, then this will give us n log x, and this is so applying exponential law of logarithm in equation 3. This is our equation 3. Log p equals to log a raised to power x. This is equation 3. If you apply this law now, we'll apply it at the right hand side of the equation. Then if you apply that, will make you 3 to turn to log p now equals to x log a. Then as we have done for equation 3, we also apply it for equation 4 as well. So here is our equation 4. Log q equal to log a raised to power y. So if we apply exponential law also, this is equation 4. If we apply exponential law also at this right hand side, and that will give us log q equals to y log a. So now let's now call our derivative of equation 3 and equation 4. Let's name them as equation 5 and equation 6 respectively. That implies that we have log, which is derivative of equation 4 now, look at our equation. Look at our derivative of equation 3. Look at our equation 3. So we want to get derivative of equation 3, and here is our derivative of equation 3. Here is derivative of equation 3. So we want to get our derivative of equation 3, which is log p equal to x log a, and we call this equation 5. Then we also have derivative of equation 4. Here is derivative of equation 4, log q equal to y log a. Then we call this equation 6. Now we now simplify equation 5 and 6. So making x and y the subject in equation 5 and 6, making x and y the subject. We want to make x and y subject in equation 5 and equation 6. So let's recall our equation 5. Here is our equation 5, which is log p equals to x plus log a. So we want to make x the subject. Making x the subject, that means we divide both sides of equation 5 by log a. Then if we do that, that implies that x now will be equals to log p over log a. That is what will be the outcome, and this is what mathematicians write as log p base a. Now we are getting expression for x, which is where we are actually driving at. So as we have gotten expression for x, we have to get for y too. Then to get for y, we use our equation 6 to get for y. So we divide both sides. We make y the subject in this equation 6 by dividing both sides by log a. So let's fast forward that. To do that, we say that y now will be equals to log y will be equals to log q. Y will be equals to log q over log a, which mathematicians write as log q base a. So as we have gotten expression for x, we have also gotten expression for y. In the previous slide, we got expression for x, which is log p base a. Then also now we've got the expression for y, which is log q base a. So we now recall back to where we started from. We started from equation 1 and 2, where we have p is equals to a raised to power x and q is equals to a raised to power y. So now fast forward, let's multiply p and q. So we say p multiplied by q, and if we multiply p by q, that will give us a raised to power x, because our p is equals to a raised to power x, multiplied by a raised to power y, because our q is equals to a raised to power. Now the next thing is, unless we apply product law of indices now, applying product law of indices, so we apply product law of indices here, applying product. If you apply product law of indices here, that will give us a raised to power x multiplied by a raised to power y. So we have a raised to power x, multiplied by a raised to power y. Then according to product law of indices, this will give us a raised to power x plus y. Now the next thing is we'll take log base a on both sides. Take log base a on both sides. Now to do that, that implies that we have log a raised to power x, log a raised to power x multiplied by a raised to power y, a raised to, and that will be equals to log a raised to power x plus y. So we can now call this equation 7. Now on this equation 7, we apply exponential law again, and we have talked about exponential law in one of the previous slides. And where is that? Okay, here is it. Here is our exponential law of logarithm. That if we have log x raised to power n, and that will give us n log x. Now fast forward, let's now apply that. Let's apply that on equation 6. If you apply that on equation 6, if you should apply that on, if you should apply that on the right, if you should apply that on equation 7, slight mistake on this derivative of equation 7, because we say that we are taking log base a on both sides, and I observed that that was omitted in equation 7. So let's write equation 7. Let's rewrite base a was not captured here. Then now our derivative from equation, our derivative when we take log base a on both sides, when we take log base a on both sides here, then our derivative is supposed to be log a raised to power x base a multiplied by log a raised to power y base a. That was what was omitted before. Is now equals to log a raised to power x plus y base a. Yeah, this is what we're supposed to get. Now we call this equation 7. Now we can now apply the exponential law, and applying the exponential law, that will make all these powers x, y, and x plus y to come down as base if you apply the exponential law, which we have already discussed about before. Then our derivative now will now be x log a base a multiplied by y log a base a, which is now equals to x plus y log a base a, and let's call this equation 8. Now the next thing we do on equation 8 is that we apply the unit law of logarithm, and the unit law of logarithm states that log a base a equal to 1. So applying this on equation 8 now, if you apply this on equation 8, log a base a here, this will turn to 1. Log a base a here, this will turn to 1. That means that the left hand side of equation 8 will be left with x multiplied by y. Also, log a base a here will also turn to 1. That implies that the right hand side of equation 8 will be left with x plus y. So that implies that we have x multiplied by y is now equals to x plus y. And let's call this equation 9. Now, we are almost there. What we need to do now is recall the value of x and y that we have derived earlier in one of the slides. Let's flip back to that. Okay, here is it. We have derived x here to be equal to, we have derived x here to be equal to log p base a, and also we have derived y here to also be equal to log q base a. These are now the two values that we recall for in equation 9. So recall that x equals to log p base a, while y equal to log q base a. Now, substituting for x and y in equation 9, then we will have x now is log p, x is log p base a multiplied by y, y is log q base a, which is now equals to x again log p base a plus y, which is log q base a. Now we are almost there. The next thing is just that we factorize here in the right hand side, and let's call this equation 10. So if we factorize equation 10, that should give us the product law that we are looking for. So we have log p base a multiplied by log q base a equals to log p plus q base a. Question easily done. And that's it. That's the product law of logarithm. So by the special grace of God, in the next video we are going to look at how to apply the product rule of logarithm. Don't forget, at MLT we are dedicated and determined in achieving excellence in all our endeavors. Try us today. Success awaits. You can visit our office, our tutorial center at Omega Building, opposite Gasland Filling Station, Obafemi Awolowo Way, Malete, Ibadan. Or you can join our virtual class, our online class. To join our online class, just put a call or a chat to Engineer Oladepo on 080-670-76871 and start preparing for external exam like WAEC, NECO, and UTME that are around the corner. We also use admission process for candidates seeking admission in tertiary institution, and we have helped numerous students to achieve their grade and secure admission into their most preferred university. At MLT, we are your road into your university. I remain my humble self, Engineer Oladepo, your host and your mere able online tutor. Don't hesitate to join us in the next video to see how we can apply the product rule of logarithm to solve simple, moderate, and complex questions. Bye for